want to next look at this question on page 13. There's the notes um, for page 12 are just hand notes or type notes in Canvas, but let's just look at this a little bit further through this video. So first we want to identify our input and output and variables. So in other words, and those letters. So we know that along the horizontal axis is going to be our input, and along our vertical axis is our output. And so this is a volume of a box. Okay, so a volume of the box created by cutting out square corners from a piece of paper and folding up the sides. So we need to know the length of the side of the cutout in inches, and we're going to name this L, and the volume of the box in cubic inches, and so this is going to be, how about V? And so our input and output and those variables in that big ordered pair, so L equals, make that a better L, so L equals the length of side in inches, comma, now our output, which is V equals the volume in cubic inches. Okay, so now our practical domain. So this problem, we want to think a little bit more. So the length. Can the length of the sides be negative? Well, we're talking about inches, so this is not possible. Anything over in the negative side for our inches is not possible. And so we're going to start with 0, and we have volume is going up, and then volume comes down based on those inches. Volume comes back down. And then, we come here and we still have positive inches, but now we have negative volume. And so volume can't be negative. So that's going to go away. Volume also cannot be negative over here. And then once we hit this negative part, none of the rest of the graph really makes any sense to us. So our practical domain is only going to go from here, this spans between 0 and it looks like maybe 4.25, if that's correct. So we're going to go, and since this is a graph that is connected at this point, we're going to go 0 less than or equal to L, which is less than or equal to 4.25. Again, we want to go from the least value, so we're always going from least, and then the variable to the greatest. So that's how we indicate our practical domain. And again, we're talking about the domain being the length. And then we want to talk about the practical range. So the practical range is our volume. And we've already kind of indicated that our volume can't be negative, and then it's not going to go up here. So our volume is going to start at 0 and go all the way up to what looks like that greatest point right here, which looks to be, let's see, 2, 4, 6, and this must be counting by 2.5. So this looks like probably 65. So we're going to go from 0 less than or equal to V, which is less than or equal to 65. So keeping in mind that this idea of practical means it's got to make sense to the problem. So just because the graph itself, so this red line starts in the negatives down here and goes negative again and then goes back up, we're only looking at the part of the graph that is makes sense to the problem. All right, so let's also look at the table here in question number 2. So the ocean temperature dropped drops fairly quickly as you descend into the ocean depths. The following table gives average winter temperatures for the Gulf of Mexico with respect to depth. So when you see this idea with respect to, we know that this is kind of the idea that the temperature, so the temperature here, and we're going to have the input be depth. We know that because depth on this table comes first or is on top. We also know this because the output depends on the input. So output depends on, because it's the dependent variable, so it depends on the input. And so this idea with respect to, so the output is with respect to the input, same idea. This depends on or with respect to is the same kind of idea. But we know if we didn't catch this wording, we see it in the table in terms of the input is always on the top of the table or on the left side of the table, and then the output comes next. So we want to define our and we want to define our variables. So we know that we have the depth, but it's missing the letter. So let's call it D equals depth below sea level in meters, comma. Now the output is going to be temperatures in degrees Celsius. So we'll just call it T equals temp in degrees Celsius. So again, writing it as this big ordered pair, we know which is the input and which is the output because input always comes before output. So the practical domain in this case, because these are just specific points, we're going to list them out. And so we're going to have 0, 40, 100, 300, and so on and so forth from the table. The last one being 3,000. And then our input, or I'm sorry, then our practical range are going to be our outputs. And we want to go from the least output to the greatest output. So really we're going to not quite write these in order because 4.073 is actually less than 4.12 and then 4.675 and so on. Here, these are correct. So there's just that one that seems to be out of order. Maybe it's a typo, or maybe it just really is that value, but we're going to write them in order. We're going to list them all out. To indicate what our practical range is for this particular problem. And the last one of 26.693, and then close. If you can't really make a brace, that's okay. Just make it look a little bit, don't, make sure it's not a parenthesis or a bracket, but make sure it kind of looks like a brace. This brace, make a little bit better here. There we go.